Hello, welcome back to 6560. So this is a short video about the last part of the greedy algorithms. We will talk about a special type of problem, knapsack problem, and we will first look at how it can be solved so we will draw some connections with the dynamic programming approach because there are two types of knapsack problem, and we will see that one of them is a discrete 0 to 1 knapsack, or the other is a fractional um, knapsack problem. So these two types of problems can be basically solved with two strategies. Okay. So if you look at the 0-1 knapsack problem, so it's basically that in this case, in this scenario, a thief robs a store and finds n items. So the ith item is worth VI dollars and also weighs WI pounds. And in this case, VI and WIs are all integers. Okay, so they are not like real numbers, but integer numbers, which means they are discrete. Okay, they can be put into grids. So he can carry at most W pounds in his knapsack. So in his bag, it also has a limit, and it's also an integer number. Okay, so that's why in this case it's 0 or 1, because he can only choose to grab or drop one item. So it's he cannot cut that item into half and just bring part of it. That's not the case. So it's either take it or not case. Okay, so the question is simple. Which items should he take, right? He wants to optimize his income, right? He wants to take as many valuable things as possible. So in this simple example here, he's constrained. The limit of his knapsack is 50 pounds. And there are 3 items available in the store. And we call them item 1, 2, and 3. And their values are $60, $100, and $120 for each. And the number here, 10, 20, 30 are the pounds, okay, the weight. Okay, so there are simply some choices we can enumerate and compare, right? We can take the first 2 items, 10 pounds plus 20 pounds, which is 30. So there's only 20 pounds left, which means we cannot take item 3 with us, okay? And that'll give us 100 plus 60, which is 160 in total. And the second way, we take the item 3 and item 1, and it gives us 180 total value. The last one is take item 2 and item 3, which all perfectly fit into the 50-pound knapsack, which gives us the maximum income for the thief, which is 220, right? So this is a simple illustration using a very simple example, but in real cases, when we have a lot more items, and we have a much bigger knapsack, then this is a quite complicated problem, and it has to be solved by dynamic programming algorithm. Okay, so there are some detailed explanations about the thoughts, but the algorithms is not provided. But you can look at the paragraphs, read the paragraphs between page 425 to 427, and it is strongly recommended. Okay. All right, so in order to compare with the greedy approach, let's look at the so-called fractional knapsack problem. Okay, and the setup is the same, but the thief can take fractions of items. Say if he wants something, then he can cut a little part of it rather than having to make a grab or drop choice. Okay, like if he saw some gold dust, then he can just take a little bit into his pockets, gold dust. Okay, so if this is the case, then the problem is totally different, and we can actually solve it by greedy algorithms. So the idea is also simple. He can just pick the most valuable item. Like he can use the VI to divide by WI, then he can get some rate, like the unit price for each item. Then he can just take the most valuable items. right? So let's go back to the example here, because for the first item, the $60 divided by 10 is 6, so that's the unit price for item 1. And item 2, it has a lower unit price, and item 3 has a lowest unit price. So what he can do is to first take all the item 1, fit all the 10 pounds of item 1, because that item 1 has the highest unit price. That's the most valuable item. Then he can also take all the remaining item 2 to fit into the remaining space, right? So we have 20 pounds left for the item 3. So we can take 20 out of 30 pounds from the item 3, right? We cut 2/3 of item 3 and fit that into the rest of the remaining space of the knapsack. And that will optimize the outcome, because this is a different problem, right? We count in fractional parts of the object, not just the whole item, grab or drop. Okay, so that is the a showcase using the knapsack problem to show how the seemingly same problem, but which actually are different, can be solved by greedy versus dynamic programming approaches. And I will recommend you to read the text paragraphs from page 425 to 427, and it will help you to understand the problem in a more detailed way.